One of the most complicated TypeScript features for a beginner are the TypeScript compiler options. And why is that? Because all the compiler does is take TypeScript code and generate JavaScript code. Well, why things are very complicated? If you take a look, and until now in this course we already did this many times, if you take a look at the generated tsconfig file.json, you'll see a lot of compiler options that might seem overwhelming in the beginning. Well, the thing is with compiler options that you can only understand them and learn them by experience. And another thing is, I think that nobody really understands all the options inside the TypeScript compiler, because everyone will use only the ones that he requires. Nonetheless, some options are more often used than other options, and some options really are more important. This is the reason I have chose to talk about at least the most important or the most popular TypeScript compiler options inside a specific section inside this course. Well, what can we expect and what we will cover? First of all, we will cover what is included or excluded for our files, these two options. We will talk about the target and the lib options, about strict checks, source maps, and CLI options. This being said, let's go to the workspace and learn more about the TypeScript compiler options. In this lecture, we will see what options do we have when we want to control what files are included for compilation and their final location. And to understand better what is included and how we can control this, I've made a very simple test project, a TypeScript project, which has a source folder, and this source folder has two files. One main.ts file, which we expect to be included in the compilated files. Usually, sometimes projects have tests next to them. This is the best practice, and these tests are called .spec.ts or .test.ts. And in this case, our tests are next to our file, but we want this file not to be included in the final compilated files. Also, we have a configuration file, which we also don't want to be included in the final files. Well, let's see what happens and what options do we have right now. Yes, and one final point. I've made this as a Node.js npm project, and we have one dependency, a dev dependency, which only contains some types for the UUID library. Just some types right here. We can also see them right here. Well, let's create a default TypeScript configuration file. So I will say here tsc ---- init. And these are the defaults. I hope that they are the same to you. If not, no problem. I think this won't change so often. Well, what can we say in order to point our compiler to our folder that we want? So let's open our configurations. And what we care about at this point is the modules entry and our root directory. And now let's say that our root directory we want to be /src. And as soon as I'm doing this, I will have a problem inside my project. Why is that? Because we have one file that is not included in this src folder. Even I will look right here. It will tell me right here, this is this config.ts is not under this src folder. Well, we need to tell the compiler that we don't want this file to be compiled. So we can tell this to the compiler by using the exclude option right here. And this is not a compiler option, so we need to get out of this object with compiler options. And right here, we can have an exclude. And the very important point about this exclude, as you can see, this is an array. By default, it contains the node modules, but I saw many people, just to be extra cautious, they also include the node modules by hand right here, even if this is implied. Well, we can say to the compiler that it should exclude the config .ts file. And now we don't have any compilation problem. TypeScript knows that at this point it can ignore this file from configuration. Well, let's see if the compiler works. So let's invoke it. I will call here tsc. And as you can see at this point, it outputted our files in the same location as they were before, and also our compiler also compiled the spec.js file, even if we said these are tests and we don't want to include them in our final product. Well, we should also exclude these .spec.js files from compilation. But how can we do this, since we don't know from start exactly their name? Well, we can use this some kind of expression. And here we can say that go right here, and then we can specify this, that here these files can be included in any folder, and we can search for all the files that end in .spec.ts. Let me delete this right here, and let's call the compiler again, and let's see what happens. And as you can see, now only the main.js file was compiled. The main.spec.ts was left behind because it is a spec file. Well, we also want a special folder to contain our files. We don't want them to be in the same folder. This is a bad practice in my opinion. I've never seen this in production. And the option that we can use, let me find it, inside the emit portion of our compilation options is the out directory. And usually we can have here a dist folder or an out folder or a bin folder, doesn't really matter. Usually I saw that a dist folder is used. Now let me delete this again and call the compiler again, and let's see what happens. So tsc. And as you can see, now we have a dist folder and our compiled files are inside this dist folder. Usually we can add this output folder under git ignore, so we make sure that this is not also put into source control. We don't want, these are generated files, we don't want them under source control. And one last point I want to make inside this lecture. We are using some node modules and we are using some types, and as you can see, sometimes you will use some external libraries for your functionality or for your types, and maybe those libraries will have mistakes in them. For example, if I will open these types and I will start to mess around with them. Let's say that you are a new version of a library, you just update it, and there's a small error or a small typo right here. I can save this and our code will still compile right here, tsc. But if I will go to our compiler options, and at the end, I guess, we have this skip lib check. This should also be true, but maybe for some reason you want to be extra cautious about your code, and we make this false. As soon as I will make this false, you will see that the compiler will also look at these libraries which are referenced by your code. So with this option, it will also check your libraries. Of course, we don't want this. Let's make it true, just as a reminder if you ever have problems inside your libraries. And keep in mind, this happens, so this is a check. We excluded our node modules from compilation, but our libraries are still checked by the compiler. Well, keep this in mind. We saw in this lecture a few options in which we can configure our code in order to have control of what enters into our compiler and what comes out of it. Let's now talk about one of the most important compiler options, and we are talking about the target. And when we want to choose a target for our generated JavaScript code, we must first answer the question, where will be this code executed? It will be executed in a modern browser, or do I want to also support older browsers or older versions of Node.js running environments? After we have an answer to this question, we can choose a target. And the default target, at least at the time I am recording, is ES 2016. This is what the TSC init command gives us, and this is a pretty safe choice. It will be able to be run in most modern browsers and also in newer Node.js versions. And why does this option have such a big impact on our code? Let's understand better what this option does right here. And for this I've created some very basic JavaScript features inside these classes right here, these files. For example, I have a class with a simple async function which doesn't even have a body. Then I have also a file with a simple class right here. And then I have a file with an arrow function. Let's try to compile this file with these files with ES 2016 with this option and see what is happening. So let's call the TypeScript compiler. And I've already set up a dist and src folder, so our files will end up in this folder. And if you look at this function, you'll see that this async function right here, this async declaration, will come into a very complicated function declaration right here, because this is something that is not supported in older versions, and for this we need to have first of all a more complicated definition for the compiler to know what the awaiter means. Also, if we look at the class, you'll see that the class is supported, so we have classes right here, and also we have arrow functions. But what will happen if I will choose right here an older version of ECMAScript, for example ES5? And just a note, ES3 is not supported anymore by the TypeScript compiler, even if the documentation currently says that the ES3 is the default target. It is not, it is ES5, but if you will choose this, you will have an error. Let's see what happens if I will choose ES5, which is also a old version of JavaScript, and let's run the compiler again. Alright, let's see now how the async function looks like. Even more complicated than before. The class is not a class anymore, it's a function because ES5 doesn't have classes. And also our arrow function right here is not an arrow function anymore, it's a regular function because ES5 doesn't know about arrow functions. Well, in this way you can understand why this option is so important and why it has such a great impact on our code. And talking about impact on the code, let's see another option, and let's try to select right here a even newer version, for example ES 2022. Or before that, let's look at the next options right here. For example, the utils entry right here, I've created a class which uses some modern JavaScript features which were introduced maybe a year or two before. And I've used these tsignore directives in order to not have any compilation errors. Well, if I will remove this tsignore right here, the compiler will tell us that, hey, you can't use this in this current JavaScript version. It will tell us that maybe I want to add this ES 2021. So I want to target a more modern JavaScript version. For this, in order to get rid of this error, let's select here a newer version, maybe ES 2022. If I would select this target, these errors should go away. And now, if I know that my running environment supports very modern JavaScript, then I can use modern features of JavaScript like the replace all function for strings or the add function for arrays. And also one very cool, relatively new feature of modern JavaScript is top level await. And this is a great feature if you are working with multiple language packages or you want to have dynamic module imports. What I mean by that? Let's look at this example right here. And in order to use this top level await, you will see this in modern websites. For example, I don't want to load all my resources into my website, all the languages that my website supports, even if the current language is English. So this is a great feature or a great use of top level await and of dynamic imports. Well, in order to use this top level await, we need a modern version of ES of ECMAScript right here, and also we need a module of ES Next. So if you want top level await, you need this ES 21, 2021 or 2022, and also right here we need ES Next. So right here I will say ES Next. If I will use this, then I will be able to use this top level await. And yes, of course, we need to make this file a module by using the export keyword somewhere. Well, this was a small talk about the top level await, a modern feature of JavaScript. If we want to support all these features, we need to use, more modern targets. But if we use modern targets, we also must make sure that our running environment supports these targets. And this is a talk for the next important TypeScript configuration that I want to talk about. And we are talking about, let me remove this. We are talking about the lib entry right here, which comes in the generated tsconfig file right after the target, because these two options are highly related. Well, let me comment this out because we will have some errors otherwise. Well, let's talk also about this lib entry right here. For example, let's open a simple entry, a simple promise right here. And I've created a file that just uses this promise constructor right here. And let's say that we want to use modern JavaScript language and modern JavaScript features, but we also want to support older browsers that only know ES5. This is only a hypothetical case. This won't happen in reality. All the major browsers support modern JavaScript. But let's say, for the sake of argument, we want to support ES5 inside our target. So let's change our target to ES5 right here. And if I save this, and this lib entry right here is also always linked by this target. So it is automatically generated or populated by the compiler based on what we are selecting as target. So most of the time, if we are selecting our target, we won't have to select our library because this lib will try to mimic our target. But let's say that we have the target ES5, but we also want to support newer versions of the language. Well, if now I'm specifying a lib entry inside my compiler, you will see at this point that TypeScript won't even know what console means, because if this lib entry is an empty array, means that we don't have any type definitions at all. So TypeScript doesn't even know what console.log means. Even if we hover over this, it will tell us, hey, maybe you want to include the DOM, so I can have type definition for the console. So right here, let's include DOM. And if I include this DOM, now TypeScript will know that what console means. But still, TypeScript doesn't know what promise means. Well, let's also instruct it to know what promise means. And for this, I can select ES2015, where promise was introduced right here. If I save this, you'll see that now TypeScript will know what promise means. This was just a demonstration for the sake of argument, as I said before. Also one problem that comes around after we select this will be that TypeScript won't know what basic objects or what arrays means, and it will have a compiler option or a compiler error right here in the tsconfig file. It will tell us that it can't find global type array. And if I want to import everything from ES2015, I can only select this, and now this error will also go away. But as I said, most of the time you will only use this target, and this lib will be automatically generated or populated by the compiler. Hopefully with these small examples you understood at least at a basic level what the target entry does and also what the lib does. I also recommend to you to read something from the documentation and to understand this better. And one other solution would also be to check and from experience to understand better how the target and the lib entries work. So you will also understand this with time. Let's move on into the next lecture and talk about another important compiler option. We are talking about the strict checks. Let's now talk about a set of compiler options that will greatly influence the way you are writing your TypeScript code, and we are talking about the strict checks in TypeScript. And these strict checks are very important. They come as standard with a tsconfig generated files, and basically they do what they say right here. Well, if this strict option is on by default, then also the others strict options will be on by default. And before going into the details, I want to tell you that this tsconfig generated file sometimes can be misleading. You might look at all these comments right here and you might see these values right here, and you might think that this is the default values. Well, this is not the case for most options, because many options depend on other options. So this is misleading, and don't always look at this and think, hey, this is on just because this commented outline right here is on. Well, this is not the case. Now let's talk about these strict checks, and let's look at some examples I've put right here inside the options of this inside the resources of this lecture. And I'm using this directive tsExpectError. Well, without this directive, this would actually be an error. And basically, when we have these strict checks on, we have this, for example, this strict initialization right here, this strict null checks. This means that all our fields or all our constants should be initialized. For example, here we are indicating that this field right here of type string is created, but this is not initialized right here, so I'm not doing this right here, and I'm also not initializing this inside a constructor. This will end up in a compilation error. In the other hand, if I will say that this field right here can be either string or undefined, well, that's safe, I wouldn't have a compilation error. And this is the case for other errors. For example, this is something called as implied any, because we didn't added any type right here, and currently our strict checks forbid us right here to have any as implied. We should either say this right here that this is any, or change the compilation option. I would say leave it like this, because this will end up in a much more safe code. Even if all these checks are hard to maintain, even if you come from JavaScript and everything is free right there, right here you have to make all these safe checks in order to prevent nasty bugs. Well, the other checks are self-explanatory. You can take your time and explore them. I don't want to waste time to read the documentation for you. I think at this point you are more than capable to do this. I just want to make one final point about this lecture. For example, here we have a, I remember when this option came around in TypeScript, I'm talking about sometimes, I want to say that sometimes options can change, or default options can change from one TypeScript version to the next version. For example, catching errors and, inside try catches blocks, errors were of type any. But from one version to another version, suddenly these errors became unknown. And this is the option right here. This is the one, use unknown in catch variables. This is by default true. So if I will make this, let me remove this directive right here. Now I will try to access an option or a field from this error which is unknown right here, and this is unknown, so I can't just make the message. Well, if I will make this false right here, then this error will go away, because at this point this error now will be any. Well, this change came around from one version of TypeScript to the other, and we just came up with a lot of errors inside our code. You know, this happens from time to time, and you have to expect it from TypeScript. Well, take your time and understand what all these options do. Again, this is something you will understand better with experience. If you want, you can take your time and play around with this example or with other examples in your own code base. Let's now talk about other things that the TypeScript compiler can emit, and we will talk about source maps and also about declarations. Previously in this course we saw what declarations do. Let's remember it. And I have here a very basic TypeScript project with one main file right here, which contains two functions and one interface. Well, if we have right now our declaration set to true and we call the TypeScript compiler, let's call it, you'll see that now we have also our compiled file, the JavaScript file, but we also have a main.d.ts file, which only contains the function declarations right here with the declare keyword. This means that this function is just a declaration, and now if I will want to add a body to this function, I will have a compilation error. Well, I also have the interface right here and also the other declaration. So with this declaration right here, we are emitting these .d.ts files, which are used as a documentation for other places in which our files are used. Let's also understand what this source map does. You know also about something about the documentation and about debugging even. Well, I have uncommented this source map and now it's set to true. So if I will compile our code again, you will see that now our code has a main.js.map. And this main.js map is an array. If I will look, it has this mappings entry with some characters you can't understand, but it is a source or a connection between our TypeScript file and our JavaScript file. And as you can see, even it says that the sources are src.main.ts. And let's see this file inside a browser. So currently I'm executing, I have a simple index.html file which makes a reference to this main.js file. If I'll inspect this inside a browser, you'll see that if I'm executing this, I will see this main.js right here. But let me save everything right here. So observe, now I have main.js, but if I will refresh this page, you'll see that now I have main.ts right here. Because if I have this source map generated, then the browser will know that it is executing JavaScript, of course, but if I want to inspect more about the code that is executed, it knows that I'm executing actually TypeScript. And if I click on this, it will directly take me to the main.ts file right here, the one that I have configured. And what's cool about this is that I have everything that a debugger offers. So if I put a breakpoint right here, remember in the main.ts file, and I refresh the page, you will see that this breakpoint will be hit even if we are doing this inside a TypeScript file. That's great, you know, and I have also a proceed option and so on, all the options that a debugger has. Well, let's resume this. We will later also see how we can use the VS Code debugger, which is very powerful. We will do this in the later sections. Alright, we saw what this source map do, and they are very useful, especially when you have complex objects or complex projects and you want to debug them. You will do this inside a browser. You can also do this inside VS Code, but a browser you will use it when you will have front-end applications. And just as we have this map for our TypeScript files right here, we can have a map right here for our declarations. So If I now uncomment this declaration map and I will call the compiler again, you will see that I will have a main.d.ts.map. And again, this is a connection between our TypeScript types right here and our IDE. So sometimes you will want to know more about your implementation from inside your IDE. You can use this main.d.ts.map right here because they also make a connection to the main.ts. Well, we saw in this lecture these optional configurations, which most likely they will assist us not on running better our code, but in debugging it. Let's move on into the next lecture and talk about some CLI options for the TypeScript compiler. In this lecture, we will see a few options that we have when we want to invoke the TypeScript compiler with some CLI parameters. But first, let's look at a small problem that might appear inside our project. Let's say that we want to support multiple versions of browsers, both modern browsers or older browsers which support only ES5. Well, or maybe we want to have a configuration for a backend implementation inside our project and one for the frontend. Well, let's say multiple TypeScript configurations. Well, what can we do in that case? Well, we can simply have multiple tsconfig files. And this is what is shown in this small project for this lecture. We have two configuration files. One, the default tsconfig.json file, and I've created a new tsconfig.web.json file. And if you name it something with tsconfig and something else, then VS Code will be smart enough to know that this is a TypeScript configuration file. So it will give you some content assist right here. You know, I have all the content assist right here. And the way we can support multiple configuration files is that we can have them, but we can also use the extends value inside the tsconfig, and this value right here, let's say that we want only to change a small portion of this configuration and the other parts must be kept. In this way, we can extend this configuration in other configuration using the extends property. Well, I can first call the extends property and then I can add what I want to be different or more. For example, I have these compiler options which overwrite the target and also the out directory. Well, the next important question is, how can I call the TypeScript compiler with these compilation options, you know, not with the default ones? Well, I know that I can do this, but I don't remember exactly how. Well, in this case, I have the option to call tsc --help. And this tsc --help will give us all the information that we want. For example, in the beginning, it will tell me I have some common commands, and it will give us some information about how can I pass some parameters to the tsc command. For example, I can pass the parameter tsc -p and then to the path to other tsconfig.json file, you know, and this will use that path. So let me try to use it. Let me clear this and call tsc -p and our tsconfig.web.json. All right, do I have a typo right here? Oh, I'm in the wrong directory. And now I have called this tsconfig.web.json, and as you can see, it called with dist/old and my main.js. What other options do I have with this tsc? Well, if we call again this tsc help, you will see a lot of options right here. Maybe, for example, we can have this tsc no emit, but one popular option which we can use with tsc in the command line, before it was also supported inside the tsconfig file, is the watch option. For example, here I can have watch options right here, and I can pass multiple watch options In the past we could have this watch set to true, but now we can only use it inside the CLI. So here I can say tsc and --watch. And now the TypeScript compiler will start in watch mode. What does this mean? Well, it means that if something is changed inside our src file right here, if I'm doing something right here, if I'm doing a change inside our source files, then the compilation will be executed on the fly. You know, like it's watching our files, and when they are changed, it calls the compilation one more time. If I will open this main.js right here, you will see that this log is renamed just like we instructed it to be. You can stop this with Ctrl and C. Alright, and let me end this lecture with one very helpful option that the TypeScript compiler gives us, and we are talking about the list files. So here I can say list files, and if I call this, then the TypeScript compiler will show me all the files that it uses in order to use the compiler and all our types and also all our source files right here. This is a very useful option when you have problems inside your code or you don't know exactly what types you have because you have a compilation error, and with these list files you can get a better idea about what the compiler wants to do.